This week we will be discussing joins. Joins are how we can include data from multiple tables in our queries. This allows us to use best practices in database design by storing data in their own entities, but being able to relate those entities to other entities, or in the database, storing the data fields separately in the tables and being able to relate those tables to other tables. For instance, a customer has a record in our customers table. They have a customer ID in customers. And in our orders table, we also have a customer ID that says which customer the order belongs to. In order to see the customer name and the order information, we need to use a join to link those tables together. It allows us to reconstruct a more flat format of our data. We do joins in our from clause. We use the join keyword to identify which tables we are joining together, and then we use the on keyword with the join keyword to tell SQL Server what columns link together. For instance, in customers and orders, it's the customer ID in both tables. So basic types of joins are inner joins. We have a couple different types of joins that we're going to talk about today, but inner joins are the easiest. Inner joins link data from two or more tables through equivalent data in both tables. So in other words, if I have a customer ID in customers and that same customer ID is in orders, both of those tables will return data and that customer will show up. If we have a customer that does not have any orders yet, let's say they're a new customer and they haven't ordered anything, an inner join would not show that customer. When we join tables, the column names do not have to be the same, but the data types must be the same. For an inner join, we either say inner join or we can simply say just join in our from clause. So let's talk about how tables link together. Let's go over to our ER diagram for our database. And we can see the links between the tables. We've got this primary key indicator here. This indicates that this field uniquely identifies any single record in the table. And we also have some foreign keys in some of these tables. A foreign key is essentially a primary key from another table. Generally, we join tables on the primary key, foreign key relationship. So if we follow the lines between our tables, primary key in customers is customer ID. We can follow that line to orders and see that the foreign key is also customer ID. In this case, we join customers to orders on that customer ID. Most of the columns that are primary key, foreign key in our database have the same name, but they don't have to. For instance, if we want to look at orders and what shipping company shipped that order, in the orders table it's the ship via field, that's the foreign key. If we follow that to shippers, it's the shipper ID that's the primary key. That's not a problem. It doesn't have to have the same name. So this ER diagram is really going to be our roadmap to link our tables up. We can literally follow the connections between the tables. So in some cases, like where we have orders and we want to know what products are in an order, there is no line that goes directly from orders to products. In order to get from orders to products, we have to go through order details, our bridge table. So let's go ahead and do some queries in SQL Server. I have my database already connected, so I'm going to do a new query. And the first thing we're going to do is we're going to start out easy. And we are going to do, here I increase this just a little bit, products with their suppliers. So list the product, list each product, and who the supplier is. So I'm going to start with my products table. Let's start with select star. We're going to come and clean that up later because when we have multiple tables, we really shouldn't be selecting star. Select star from products, P. That's my alias for products. And now I want to join or inner join. So inner join suppliers S on. This is where I tell SQL Server what two columns in those tables match up. So if we go back to our ER diagram, we can see that both tables have the supplier ID. The products table and the suppliers table link on the supplier ID. So we will join using that column. So the product supplier ID equals the supplier's supplier ID. So now let's clean up our list of columns. I say I want the product name, product ID, and then the supplier ID, supplier name. And when I run that, I can see each of my products, and I can see who the supplier is on each of these products. Now, the supplier ID is in both tables, so I could include it from products or suppliers. It really doesn't matter in an inner join because the data has to be in both tables. So when I run this, you'll see it's listed twice. However, because this column does exist in both tables, I have to have my table qualified here. So for any of the rest of these fields, I can get rid of this table alias in front of the column name. And I don't get any red squiggles to indicate there's a problem. If I do that for my supplier ID, I'm going to get red squiggles, and if I hover, it tells me ambiguous column name supplier ID. That's an indication that that column exists in more than one of the tables listed. So in this case, we have two tables. It's in both of them. If we have more than two tables, it just means that that column is in more than one table. So I have to qualify the column. So I want the supplier ID from products, or I want the supplier ID from suppliers. Again, in the case of an inner join, those values have to be in both tables, so it does not matter which table we pick it from. Okay, so let's do another example. Let's show the shipping company that shipped each order. So back to my ER diagram. I want to know order information, so I'm going to start with orders. And I want to know the shipping company, so I need to join to the shippers table. So this is that one case where the field names don't match. So I'm going to start with select star. We'll come and clean that up later. From orders O, join shippers S. So the on clauses, again, how do these tables join together? So in orders, it's the ship via field. So I can see that right here. That's my link. And in suppliers, it's the shipper ID field. So the ship via equals the shippers table, shipper ID. So I'm going to pick the order ID, the order date, and shipper's company name is shipping company. So that shows me for each order which company shipped it. So let's keep going with this example. Let's say we also want to know the products for this. And since this is a lot of orders, let's just stick with one order. I'm going to copy and paste this so that I can post this for you later as a demo script. So, information for order 10248. We'll just pick the first one. Include order information, the shipping company, and the customer name. Okay, so if we look at these tables on our ER diagram, customer name isn't in orders. All we have is our customer ID. And the customer name isn't in shippers. So we need to join in a third table, which is the customers table. So to do this, I'm just going to add another join. I'm going to join in customers. Now customers joins to orders. It doesn't join to shippers. A lot of times students tend to get confused that how can they join this table in? The last table I joined in doesn't have the column I need. As long as the table you want to join to is listed somewhere beforehand, so in this case we need to join customers to orders. Orders is listed in my from clause before customers. I can join to it. So join customers on the customer's customer ID equals the order's customer ID. And now I can include CDOT company name as customer. And let's include the customer ID from customers. And let's limit that to order 10248 with our where clause. Okay, so one order. This is for customer ID Vinette. Order date July 4th, 2013, federal shipping. Let's keep going with that. I'm going to copy again. We're going to include the products that were ordered. So if we go to our ER diagram, we currently have the customers, orders, and shippers table included in our query. We need product information. Again, there's no line that goes straight from orders to products. In order to get from orders to products, we have to go through order details, which means this is the first table we need to join in next, and then we're going to join in the products table after that. So back in my from clause, I'm going to add another join. Join order details. I'm going to alias this is OD. And this joins on the order ID, and I can see that with the relationship line here. So order ID in both tables. On O.order ID equals OD.order ID. So let's include something from order details here. Let's include the product ID and the quantity that the customer ordered. So when I do this, we're going to see something a little bit interesting. All of a sudden, instead of having one row, we have 3. This is because the customer ordered 3 different products on this order. When we are joining data, we are reconstructing a flat layout. So since we had 3 records in order details to represent each product, all of the rest of the fields get repeated 3 times. So this still represents the same one order, but there's 3 products. Now to get our product name, we need to join in our products table as well. I'm just going to move these up to get a little bit more space. So we'll add another join products, P, and this joins in on the order details product ID equals the product's product ID. So same column name in both tables. On od.productID equals p.productID. So now I can include p.productName. So this is what this customer ordered. And we could keep going further if we wanted to. We could include the employee who helped the customer with the order. We could include the supplier of the product. We could include the category of the product if we wanted to. Any of these tables that link up, we could join in somehow to this query, but it doesn't always make sense to include all the tables, so we're just going to take it as far as we need to. So with this, let's go through a couple common mistakes in making joins. Number 1, not actually joining your tables. If I try to join products to suppliers but forget to use my join condition, we are going to end up with a lot of extra rows. So if I do select star from products P, suppliers S, and I run this, I end up with 2,200 some records. So what happened here is instead of, let's see, select star from products, instead of only getting 78 products with the matching supplier, what happens here is I get every product listed with every supplier. So if I narrow this down in my select list, we'll be able to see that. So every single product first gets listed with Exotic Liquids as the supplier. And if I scroll down far enough, you'll see that my product IDs start over again with the next supplier. What we've done here is actually created a Cartesian product. So for every record in the first table, it is matched to every record in the second table. So M times N. M records in the first table, N records in the second. This does not work correctly. It creates a Cartesian product or a Cartesian join. So this one should be pretty easy to identify. If you know there's 78 products and you're looking for a matching supplier, you shouldn't end up with more than 78 products in the end. Mistake number 2. Not 32. Number 2. Joining on incorrect fields. So joining tables on incorrect fields. So in our PowerPoint, we said the column names don't have to be the same. The data types have to match, though. What this lets us do is cause problems for ourselves, honestly. If we go to our ER diagram, we can see that suppliers is supposed to join to products on the supplier ID. Supplier ID is an integer in both tables. But in products, my product ID is an integer and my category ID is an integer as well. So technically, I could join these tables on any of those fields. It would just produce a result that doesn't make much sense. So let's go ahead and do that just to show it. So select star from products P. Join suppliers S on P dot, let's say I pick the product ID equals the supplier ID. These are not fields that link up. However, since they're the same data type, I will get data. And if I pull these, and it's not always going to be easy to see in this case that I made a mistake. However, we know from before we had 78 records. Each product should have a supplier. All of a sudden I have 29 records now. That should be an indication that somewhere the data went missing. So you want to check your on clause. So in this case, we went from 78 records to 29. This should indicate a problem. Okay. We also could have done it incorrectly. Let's say we did the category ID instead. In this case, we still have 78 records. And this one is not the easiest to see that there's a problem. So, if we're not sure about our joins, we know that the supplier IDs are what should match in these tables. So if we aren't sure that we did it correctly, I can include the supplier ID from products and the supplier ID from suppliers. And these should match if I join my tables correctly. But what we'll start to see is we have some records where these don't match. And that's a problem because they should if we joined on that field. So until you get really good at joining tables, you might want to pull in both columns that you've joined on just to make sure to visually verify that you did this correctly. Okay. So neither of these work correctly. I'm just going to put some notes in here, so if you're looking at it later, you understand that these aren't right. So another thing I want to talk about with inner joins So we've been using the aliases here. This is the correct join for this. So these actually join on the supplier ID. However, if you're not a fan of using aliases, you can rewrite this without aliases. So instead of P, I have products, and I have to get rid of all of my P's because they don't exist anymore. And I have suppliers S. So if I get rid of my alias S, I have to get rid of it everywhere. Now for these columns, SQL Server knows where they come from because they're only in one of the tables. Supplier ID is in both tables, so I still have to qualify my column. But I can do that by saying products.supplier ID or suppliers.supplier ID. And I have to do the same thing down here in my on clause. So these two queries here produce the same results. One uses the aliases, one does not. Going back to our PowerPoint. So when we do our inner joins, it doesn't matter which table we list first. So I could write this same join the other way. So instead of products to suppliers, I could do from suppliers join products on the product or on the supplier IDs. It produces the same results. So in an inner join, which table is listed first does not matter. Table order is different. Results are the same. Now we want to talk about another type of join. Where clause joins are something that was done in the past. They do not conform to ANSI standards, so the standards that govern SQL, but they're often used in older systems. This is absolutely not recommended to do. So if you know how to write a where clause join, I will not accept those on the homework for this class. We are writing ANSI standard SQL, which means we need to do our joins in our from clause with our join and on keywords. I'm not going to go through how to do a where clause join because I don't want to confuse anybody. But if you know how to do them, do not use them in this class. Okay, we talked about qualifying column names. Now let's talk about outer joins. So if we look at, I'm going to open a new window here. So if we look at our customers, I'm going to make the text a little bit bigger for you. I have 92 customers. And if I want to know customers and their order information, $92 customers total. From customer C. So I'm going to use an inner join, which again could just use join. Join and inner join are the same. So inner join orders O and C.customer ID equals O.customer ID. Let's include customer's name, the customer's ID, customer's name, and the order ID. If I run this, I get 831 records. How would I know if I had all of my customers included here? I really wouldn't with the way this query is written. However, if I get rid of my order ID, I'll still have my 831 matched up records, but I could put a distinct here. Show me the distinct customers that have orders, which shows me there are 90 customers with orders. That means that 2 of my customers don't have orders. So if I want to find those people, I can't use an inner join. I would have to use an outer join. So outer joins let us include rows or records from one table when there isn't a match in the other table. So if I want to include all of my customers and show an order if they have one, but still show the customer if they don't, I need to use an outer join. So columns from the table where there isn't a record will get a null value listed for that column. And we have 3 types of outer joins. So we have to use outer join and our from clause, and we have to use left, right, or full. And we're going to talk about the difference between the 3 now. We'll come back to this slide. So left outer joins. The table listed on the left side of the join keyword is where we get all of the records from. The table on the right side we get the matches from. This is the most common type of outer join. Way back when SQL was first starting, left outer joins took less processing power than right outer joins, which we'll talk about next. So even though today right outer joins and left outer joins take the same processing power, because historically left outer joins were more efficient, people always wrote left outer joins, and we've kind of carried that over, and so most people still write just left outer joins. Right outer joins means the table from the right side of the join keyword is where we get all of the records from, and we get the matches from the table on the left. Any query that uses a left outer join can be written as a right outer join, and vice versa, simply by flipping the order that the tables are listed in. Now we also have something called a full outer join, which means we get all records from both tables, and we get the matches where they happen. There aren't any really good examples of full outer joins in our database, so we're not going to use that one. And out in the wild, it's really rare to ever need to use a full outer join. I think I've written 3 or 4 queries in 10 years that have actually required a full outer join. So in this class, we don't need to write any full outer joins, but be aware that they exist. So let's write a couple outer joins here. If I want to see all of my customers and their order information, if they have it, I need to get those 2 missing customers back with my outer join. So show all customers and their order IDs if they have orders. So I'm going to start with this. Now I'm going to remove this inner join because this is no longer going to be an inner join. And I'm going to remove our comment. Here's where we have to decide if we want a left or a right outer join. So if I want all records from the customers table, customers is located to the left of the join keyword. It's on the left side of this join keyword, which makes it the table on the left. Therefore, we do a left join or a left outer join. This outer keyword is optional. So a left outer join to orders. We don't change anything in our on clause, just in our join keyword here. So now if we do c.customer ID, c.company name, and o.order ID, we'll see we have 833 rows now. Before we had 831 when we joined the two tables together. If I scroll through here, eventually I should see a customer somewhere that doesn't have an order ID. And they're listed at the bottom. We have two customers here, Fissa and Paris, who don't have any orders. See, these are our two customers without orders. So we're going to limit this a little bit so we can look at this a little bit further. So I happen to know that at least this company is located in France. So we're going to include order information for customers in France. So all customers in France, their order IDs, and products on the orders if they have orders. So let's limit this to France. So we see Paris here still is included, still doesn't have an order, and we've limited to 78 rows instead of our 833. Now if we want to include products, we go to our ER diagram. Again, from orders to products, we have to go through order details. So I'm going to rate this, and then we are going to look at the results and determine if we did this correctly. So we know we have a customer that doesn't have an order, but we want the order details table joined in next, and we want the products table joined after it. So I'm going to join order details, and this joins on the order IDs. You can see that from our ER diagrams, order IDs. So on the orders, order ID equals order details, order ID. So when I do this, I now have 184 records. Because if I look at order details and add the product ID, I can see that there's multiple products on each of these orders. That's why I get extra records. So if I scroll through, I've got a lot of records. But as I scroll through, it kind of looks like the customer ID Paris might have gone missing. So I'm going to add another item to look for them. So, and the customer ID equals Paris. They don't show up anymore. What happened? We wanted all the customers in France, not just the ones with orders. Well, this is the slide we skipped, so I'm going to go back to that one. When you have outer joins and inner joins, you really have to be careful. So you can have inner join, inner join, inner join. As soon as you have one outer join, you have to continue using outer joins or you're going to start losing records. So we had an outer join to start with. That means we have to have another outer join here. Because when we have this, let me go back to this. For our customer, Paris, at the bottom here, their order ID is null. And when we joined in order details using an inner join, we said the values have to match. But there's no record in order details with a null order ID. That's why this record got lost. So again, we have to figure out, do we want a left outer join or do we want a right outer join? It's a little bit harder when these things are on multiple rows, but we can always move these up. And we can see that what I want, the customer I want all the records from, the table I want all the records from, customers, is still on the left of this join to order details. So it's still a left outer join. Or in this case, I'm just going to use left join to show you that they're interchangeable. So that outer keyword there is optional. So now if I do this, we see that they exist again. So I can get rid of this, comment it out, to get all of my customers from Paris again. And when I scroll to the bottom, they still show up. So if I want to include my products as well, we're going to have to use an outer join again. And it's still going to be a left outer join. So left join products, P, and order details product ID. Product ID to product ID, that's how they join. You can follow this line. So order details product ID equals the product's product ID. And then I can include the name of the product. And again, if I go to the bottom, I can see that Paris Specialties is still included in my results. So that's one way we can use an outer join, is to combine information from tables where we might not have records. Another way we can use it is to find things that are missing. So we talk about we just want to see the customers without orders. We have this query that shows all the customers and the orders, if they have them. What we can see is that the customers without orders have no order IDs. So we can look for that condition with a where clause and say where the order ID is null. They don't have an order ID. And these are our two customers without orders. So switch back to my PowerPoint here. So our full outer join, we'll do an example just so you see the syntax. All customers and orders. So we would just do full outer join here. This isn't going to return any different results in our database because we don't have a good example. But if there were orders that didn't have customers, which we should never, ever, ever have, every order should have a customer, but if there were, they would show up, as well as the customers who don't have orders. So we still have our customers who don't have orders. We don't have any orders without customers. But that's our syntax for full outer joins. Okay, let's move on to our last type of join. It is a special type of join called a self-join, and it refers to when we join a table to itself. So a table will have a column that refers to another column in that same table. Some common uses for this are the employee to manager relationship or the categories to subcategories relationship. In this case, we have to use table aliases. We can't get around it. And we have to use column qualifiers. So we have to tell SQL Server for every column which copy of the table it comes from. So I'm going to have another new query here. And I'm going to bump that up. Self-joins. So if we look at our ER diagram, there is one table in our database that has a reference to itself, and that's our employees table. So employees report to somebody who is also an employee, so it's kind of a circular-ish reference. That's our self-join condition. So I'm going to write this join, and I'm going to talk about it a little bit, and then we are going to check to make sure we did it correctly. So list employees and their managers. So I'm going to start with select star. We'll come back and clean that up. From employees, call this E1. Join employees, E2. On E1 dot employee ID equals E2 dot reports to. So before we run this, notice I use different aliases, but do these aliases really tell me anything different about these tables? Do these aliases tell me which one is the employee and which one is their manager? It doesn't. So these aren't really good aliases. So we are going to try that again. So when you use self-joins, you want to make sure you use good aliases so you remember which table, which copy of that table represents what. These aliases are confusing. So let's use better aliases. Oh, instead of E1, let's call this E. This represents the employee. And instead of E2, let's call this M. Represents the supervisor. So again, I have to fix these. So now, I'm going to say E dot employee ID, E dot last name, E dot first name, M dot employee ID, M dot first name, M dot last name. And I should use some aliases. So this says manager first name, that's manager last name. Because otherwise we don't have any context to those columns. Okay, so let's run this and verify our data. Okay, so I've got the employees and their managers. Did we do this correctly? Well, let's look at the employees. Why do I have the same employee listed multiple times with different managers? I only have one. Should only have one value in this reports to field. If I look at what I did, I said the employee's employee ID equals the person the manager reports to. So I did this backwards. So our first note should be to see that the person listed as employee is listed more than one time with multiple managers. That should be our first note to self that something is wrong. The second thing that we could do is we could use the employees reports to, that's who they report to, and the manager's ID, and display them, because those things should match. But in our case, they don't, because we did it wrong. So I wanted to show this example because every semester I see this done backwards. So just want to make sure we talk about it. Let's do it the right way. So employees and their managers, done correctly. This still represents the employee, this represents the supervisor, manager, the M is for. And we need to flip these around. So the manager's employee ID equals the ID of the person the employee reports to. Now if we run this, we see each employee listed once. We see the managers. Looks good. But do we have all employees? We see 22. 22 IDs, 21 records. A simple count from our employee table should show us. So we do select star from employees. We had 22 records, but this only shows 21. So somebody is missing. So if we look at our employee information, and we look at the reports to field, we'll see that this person doesn't report to anybody. That's our CEO. He reports to the board, but the board isn't a person. It's a group of people. That's why he has null. So if we want all the employees, we have to do something else. Almost correct. The CEO is missing though. So we're going to take this, and to fix this, to get all employees plus managers if they have them, we need to change this to an outer join. So again, if I get rid of this comment, I want all of the employees. Employees is on the left of the join condition, therefore I want a left join. Does not have to stay on the same line, just to illustrate how we decide this. Now, we have all 22 employees here, so that's good. If we wanted to know active employees, then we could remove the people with termination dates. But to get a full list of employees and who they report to or who they reported to, this will work. So self-joins, when we do a self-join, we don't actually use a self-join keyword. Self-join just refers to the fact that we are joining the same table to itself. So self-joins could be inner joins or they could be outer joins. We just have to determine which scenario we want. We want people to show up in this if they don't have a supervisor, or should they be excluded? Depends on the circumstance. So, let's talk real quick about inner joins versus outer joins and when do you use them. If I want to know something like all products, including those that are not ordered, this is an outer join situation. If I want to know products that were ordered, that's an inner join situation. So when you do your queries and you're not sure, think about, do we want all of something and matching information, or do we not care about the records where there might not be a match? This is something you will have to decide on a case-by-case basis. We will go through a few more examples of this in class, though. So that is all I have for this PowerPoint and this video lecture. So I will see you all in class next week, and we will show some more examples.